The date? March 24th. I know, it might look like just any other day on the calendar, but trust me, for our story today, it's the hero. Because on this one single day, stretched out across different centuries and all over the world, a few brilliant minds were either born or passed away. And in doing so, they completely changed the world we live in. So let's meet them, one by one. Okay, let's kick things off with a modern mystery. How in the world can a camera see something that's totally invisible, like heat? How does it build a picture out of nothing but temperature, even when it's pitch black? Well, the answer takes us all the way back to March 24th, 1835, and the birth of an Austrian physicist and mathematician named Josef Stefan. So here's what Stefan figured out. He discovered this fundamental law of the universe. Turns out, there's a super precise mathematical rule that connects an object's temperature to the thermal radiation. It's like a kind of invisible light that it's always giving off. Basically, the hotter something is, the brighter it shines in this invisible spectrum. And that right there, that's the aha moment. It means everything with any heat at all, and that includes you, right now, is constantly broadcasting its temperature out into the world. A thermal camera is just a device that's finally built to see that light. So let's go ahead and place our first pin on the timeline. Boom, 1835. Josef Stefan is born on our special date, and he gives us the physics of thermal radiation. But believe me, our story is just getting started. Let's stick with March 24th, but let's jump forward in time. Now, think about a problem we've all had, right? Tangled wires. Is there a real, actual mathematical difference between a messy loop that you can just pull apart and a true stubborn knot? Oh, there is. And the answer comes from the work of Ralph Fox, an American mathematician who was born on, you guessed it, March 24th, 1913. Fox was one of the pioneers of a field called knot theory. And yeah, it's exactly what it sounds like, the mathematical study of knots. It's absolutely fascinating. He came up with these incredible ways to describe knots using algebra, creating these unique fingerprints for them that don't change no matter how you twist or stretch the rope. It lets us tell if two tangles are mathematically the same or if they're fundamentally different. And that's the whole idea, isn't it? Math can find this beautiful, predictable order in something that just looks like pure, frustrating chaos. And this isn't just about shoelaces. This work is used today in everything from understanding how DNA works to quantum physics. Okay, back to our timeline. Let's add Ralph Fox. Same date, connecting the physics of heat to the abstract geometry of knots. One day. So many incredible stories. All right, let's go even deeper now. We're going from knots to the very building blocks of reality. What are the rules that run the bizarre secret world of quantum mechanics? For this one, we turn to Francis Murnaghan, an Irish mathematician who passed away on March 24th, 1976. So Murnaghan was a master of a field called group theory. Now, that might sound intense, but you can basically think of it as the mathematics of symmetry. And he showed how these abstract patterns of symmetry give us the perfect language to describe the strange, almost magical behavior of particles at the quantum level. Just think about that for a second. The most fundamental rules of our entire universe aren't just a bunch of numbers and formulas. They're expressions of these perfect underlying patterns. Murnaghan helped physicists learn how to speak that language. Let's go back to our timeline and add Francis Murnaghan. From heat to knots to the quantum world, all of it connected by March 24th. And we've still got one more stop to make. Our final question takes us into the world of art and technology. How do artists, and now computer programmers, create that illusion of three-dimensional depth on a totally flat surface? You know, like a canvas or a computer screen. Well, the mathematical rules for this were the life's work of Leopold Klug, a Hungarian mathematician who died on March 24th, 1945. Klug was an expert in something called projective geometry. This is the math of how shapes change when you project them. You know, think about how a perfect circle can look like an oval from the side. This math looks for the hidden properties that don't change. For instance, a straight line, no matter how you look at it, always projects as another straight line. These are the exact rules that power the 3D graphics engines in all the video games we play and the CGI we see in movies today. And that, right there, really gets to the heart of what he was doing. It's this search for the essential, unchanging truths of a shape, no matter what our changing point of view is. And there we have it. Our timeline is complete. Josef Stefan, Ralph Fox, Francis Murnaghan, and Leopold Klug. 4 incredible thinkers, 4 completely different fields, all connected by this one golden day, March 24th. So what is the common thread here? What did all of them have in common? Well, every single person we met today was a seeker. They were looking for the hidden rules, the secret language, the unchanging pattern that's hiding just underneath the chaos of the world. And because they asked these questions, our world is so much richer and more understandable. It really makes you wonder, doesn't it? If one single day can connect all of this, what other secrets are out there?